with Habitat Charlotte on two projects. The first project is a weatherization of an existing home, and that started today. 4 of us came directly from that project here, and they did the pre-test, the blower door test, and the evaluation of the home. This Saturday, we have about a dozen volunteers from the chapter who are going to implement all of the weatherization improvements that were recommended by this test today. And then next Wednesday, we will have a post-test to make sure that the items that were improved in the home actually improve the efficiency of the HVAC system and the seal of the building. So we're excited to be involved in that. This is a new venture for Habitat Charlotte, one that they hope to continue, and one that we hopefully will be able to continue helping with. The other project that we have is February 19th, a week from this Saturday, and we have approximately 20 volunteers signed up for that. And it's a work day for Habitat Charlotte's first LEED registered home. So big hand for Habitat moving forward with LEED for homes. On February 19th, we will be wall framing for the home. So if you are interested in swinging a hammer, then contact Matt PC, the email listed there, and see if we can fit you in on February 19th. And thanks to those who have already registered. On February 16th, we will have our statewide advocacy day. This is where all 3 chapters in North Carolina have representatives going to Raleigh. And we have, right now, we have about 30 legislators that we have appointments with on next Wednesday, February 16th. And so we will get to sit down and have FaceTime with them, talk to them about what's going on in the state and in our particular region as far as green building and sustainable design goes. So we're very excited to have one-on-one FaceTime to promote sustainable causes, to promote USGBC. Volunteer Recognition Program. If any of you are familiar with anyone who's active in our chapter, you know that we make all these wonderful things happen because of our volunteers. And we have implemented this year a volunteer recognition monthly program. And the nomination form is located on our new website and due by the 5th of each month. So you've got until March 5th to submit nominations for the month of February. So we hope to see some great nominations coming in for our wonderful volunteers so that we can recognize them and appreciate all of the hard work that they do. On the center of your table, please, if you want to do it right now, that'd be wonderful. Take the comment card. This is going to help us provide the content the way you need it and what you want. So please give us your feedback. We're an organization that's here to serve you as our members and as our interested parties, so we want to know what you need. Also, we will be filling out a course evaluation. Disregard, leave on the table because it's not on your table. The course evaluation will be sent out electronically, and it will allow you to evaluate this course and future courses as we go forward. And non-members were tagged as they walked in the door, and I would like to ask Jan Sowell to come up front. We are going to do a raffle for a USGBC Charlotte Region Chapter membership. And Amy Height is coming. Amy Height is the chair of our Membership and Outreach Committee. Michael Morris.
He just walked in.
Congratulations. So Michael Morris, you are the newest member to USGBC Charlotte Region Chapter. I have to tell you that our sponsorship drive is continuing for another few days. We are trying to wrap up this year's campaign by February 15th, which is Tuesday. Can you believe it's mid-February already? Thank you to the volunteers who have made phone calls and solicited sponsorships so far. If you're on our volunteer call team, would you please stand up? If you have been active in soliciting volunteers, Heather Butler. Thank you very much for the work that you've done. We truly appreciate it. And thank you to the sponsors who have come to the table new this year, and to those sponsors who have renewed with us. We truly appreciate and could not accomplish our work without our volunteers and without the support of our sponsors. It takes time and money and dedication, so thank you for helping us complete that equation. And if you have any last-minute aces in the hole that you want to let us know about, we're here. Talk to me. We'll make those phone calls before Tuesday. Continuing education units for USGBC credentials. This course will get you one CEU, and you will be emailed that certificate. And for our members, you will also be able to go on our website, log into your profile, and your certificates will be listed there as well. So you have this repository of all of your continuing ed units whenever you get ready to log them in to the USGBC GBCI system. So that is just an added benefit of our new website. We're going to catalog those continuing ed certificates for you. We are very excited about this second item. Charlotte Region Chapter footprint is 37 counties in North Carolina. Predominantly, we're active in Mecklenburg. We want to extend into the rest of our footprint. One of the ways that we are going to do that is offer these meetings through webinar or webcast. And so today is a trial. We have Matt McNeely at the table today practicing. We're going to see how it works today. And if it does work successfully, we're going to continue for the next couple months, offer it to our members, advertise it. And so for those people who it's not convenient to come to the meeting, you can log in and view the course by webcast, still receive the 1 hour of continuing education, and receive your certificate. So we're very excited about this green way to learn. And effective April, this is our last bit of business here, to promote people to register in advance for our courses and our events, we are going to be implementing in April a $30 flat rate for walk-ups. So we hope you understand that due to planning for lunches and paying for lunches and reserving the room space, it's best if we know in advance who's coming and how many people to expect. But we understand busy business schedules. So if you don't know until the last minute if you can make it, we still want you here. We're not going to turn anyone away. But the fee will be $30. So thank you for understanding that. And I just had a screenshot here to show you what it's going to look like. When you log on to our website and into your profile, you're going to go to the Files and Links item on the right-hand column. And under Files and Links, a screen will pop up and it will show you your certificates. So if you've attended 5 events this year and all of them have CEUs, you're going to have 5 certificates there. Okay, so hopefully you will find this a valuable resource. We think it's a very, very valuable resource for you. And if you have any questions with that, you can contact Matt McNeely, Misty Beller, Sandra Doherty, or myself. Thank you for your time. I'm going to turn it over to the chair of our board of directors, Chris Studney.
All right, good afternoon. Just curious, how many lead APs are in the room? Wow. So does everybody, well, make sure you get a copy of the test for today's program. It's in the center of the table. So you can fill that out. No, I'm just kidding. How many of you have actually been to our website and created a profile? Excellent. So that'll be a great place to get our CEU certificates, as Emily just said. Just a couple things. Our program next month is going to be on hydrogen technology and the future of urban transportation. We'll also have CEU credits for that as well. And we have a panel discussion we're working on for local retailers in the Charlotte area, how they're going green. Some companies like Harris Teeter, Family Dollar, Food Lion, and hopefully Lowe's, and a few others. So keep your eye out on our website for details on that. I'm just going to do a quick introduction for Andy, our speaker today. He's a graduate of Georgia Tech. Asked me to ask all the Georgia Bulldog fans to leave, if you could, before we start. Just kidding. He's got 14 years experience in the business in areas such as civil site development, roadway and drainage design, potable water and wastewater systems, stormwater and erosion sediment control, utility design, just a tremendous amount of knowledge and experience. He's a project manager for EMH&T, who's a full-service civil engineering firm. Helped establish their Atlanta office in 2008, and I think just recently relocated to Charlotte to help expand their municipal and institutional and residential portfolio. He's a chapter member and a lead AT, so please welcome Andy.
Thanks. I hope I didn't offend anybody with the University of Georgia jokes. Some of my best friends are Georgia fans and Clemson fans. So if you are one, there's going to be a word search at the end of the presentation. Maybe we'll pass out some pictures to color also. Is there any civil engineers in the room? Oh, wow. Okay, so I guess I can't fake it through the presentation today. I have to actually be on target. Well, thanks for having me today. The name of the presentation is called Green Sites for Green Buildings. We go into sustainable stormwater management and how we can incorporate some more sustainable practices in the site design work that we do. A little bit about EMH&T. We're headquartered in Columbus, Ohio, offices in Indianapolis, Cincinnati, and Charlotte. We did have an office in Atlanta, decided to relocate here to Charlotte. Things are going a little bit better here, so we do a lot of different things related to civil engineering, anywhere from traffic engineers to even archaeologists that we have on staff. So, does everybody hear me? Oh, yeah. Okay. Webinar mics here. So we've been doing this since 1926, and I'm happy to be the newest member in our Charlotte office here. Moved here in August. For anybody that's AIA members, we'll have a CEU, a learning unit CEU for you. Bethany from our office has a registration form for that at the end if you want to sign up at the end. So I'm going to go over the learning objectives for today, some of the things we're going to talk about. I want to just go over a few terms, that might be thrown around a lot here recently and how they relate to stormwater management and sustainable site design. Definitely want to go into sustainable infrastructure techniques, the best management practices that we use in trying to make our site designs a little bit greener. Analyze the basics and planning of sustainable infrastructure. We're going to go into a brief case study on a project that we worked on here in the city of Charlotte. One of the first underground detention projects that had water quality associated with it. So go into that a little bit. And then also we've got a couple design examples where we sort of started with a conventional site design that you would see every day and then put some brain power to it and turn it into a greener, more sustainable site. So we'll get to that at the end. So I'm excited about going through this. I usually try to make these as interactive as I can, but since we have such a big crowd today, if you have if you really see something that you don't agree with or don't like, you can jump up and yell. But otherwise, just at the end of the presentation or ask me afterwards, I'd be happy to answer any questions. So I want to talk a little bit about some terminology and, of course, sustainability, and everybody may have their own definition of that, or at least heard a definition. But, being able to do things in our field of work today that will allow for our children and next generations to do those things as well. We talk about low-impact development and best management practices together. Low-impact development is kind of a catch-all for the types of land development work that we try to incorporate more sustainable practices into. The best management practice is, anything from a stormwater pond or a vegetated swale, or things that we design stormwater-wise, to do low-impact development. Now, BMP is really a noun, and today, we've gotten into terming these things either good best management practices or not so good best management practices. Green streets is one that you'll start to hear a little bit more about, specifically related to stormwater. Green Streets is an initiative that many cities are taking on today to try to keep runoff associated with the street close to the source. And that means extending landscape islands further into the street, narrowing down lanes, trying to provide some stormwater treatment and runoff control in the street right-of-way itself. So we'll talk a little bit about that as well today. You might see a lot more of that in Charlotte. So I want to talk about, we talk about sustainable stormwater. Well, let's identify what unsustainable stormwater is. And you can see some pictures here of maybe some problem areas. But unsustainable stormwater is site designs or construction that allows runoff to carry pollutants into natural waterways and score out channels of streams, contributes to flooding, runoff that erodes natural channels because of the velocity of the discharge. These large conventional detention basins that heat up water, stagnate the water before they're released into natural streams. And then, simple fact of detention that we do by holding water back before we let it go into a stream. Sometimes we hold that water back and then let it go at the worst possible time, because it kind of coincides with all the flooding that's coming down from the upstream channels as well. So if you think about a conventional detention basin, I'll go back to that example a little bit as we go along, but you can picture maybe a big box shopping center tenant or something like that, not to pick on that type of development, but you have maybe a large rectangular shape or triangular shaped detention pond in the back, very steep side slopes, probably has an old chain link fence around it, maybe a ring of trash around it as well. That's what I consider to be your conventional detention basin. And if we can do some things to not get rid of, but to try to get away from that as much as possible, and you'll see why that becomes more sustainable. So I want to talk about the sustainable stormwater strategy, some of the things that we will try to do in our design and our construction and our project planning to be more sustainable with stormwater. The best thing to do is first of all, is just reduce impervious area. Now, that's not always a luxury, but if there's planning that we can do in the beginning to reduce that overall footprint of impervious area to try to provide more green spaces, then that's one of your best strategies. If we can provide infiltration into the groundwater, the simple act of the water percolating into the sandy soils, that's a great way to remove pollutants. We try to mimic natural hydrology. If there's opportunities to convey stormwater through natural channels, through ditches, areas of vegetation other than steel pipes or concrete pipes, then we're providing a more sustainable alternative. If you're a lead AP, you know that in our certifications we have to decrease runoff rates and provide stormwater quality, and we have to do that in most jurisdictions as well. So we use the stormwater, kind of a palette of stormwater best management practices to do some of these things. And I want to go over several of these. Some of them you probably have heard of, some of them you may have no idea, somewhere in between possibly, but I'd like to touch on these as we go along. And if you have any questions, kind of make a mental note and feel free to ask me at the end or afterwards. But the first one we're all familiar with is a stormwater basin, which is interchangeable with pond, detention pond, basically a hole in the ground that stores stormwater and releases it for, at a later time. I picked on the conventional detention basin.
Got your email on the schedule of values
ponds
that
are
you
a fact
sent
of
over.
life in the developing community.
And I was pulling it up, and I also pulled up
They don't always have to be bad.
the original one that was sent to Catherine, and she
dry
had
detention
requested
basins that
some
store
modifications
water
to
and
it.
let it
But I
go,
don't see the
and it
modifications on
filters
this
down,
updated
or
one.
wet detention basins that we try to
wanted to know
incorporate
how
as
you were planning
amenities
on
in the site
handling
designs
that.
that we do.
You can give me a
But
call. I'll be here till about 1 o'clock, and then I'll
settle out to mix in and then release provides some better stormwater quality as it goes downstream, and also sheer fact of flood control. So if we can provide some creative areas to move water around, aeration, certain plantings in our detention. Some of the things that we try to do to make our stormwater basins or ponds better, we try to shallow the side slopes, not have such a steep side slope that can erode more easily. If we have the soils, and it's kind of hit or miss in the Carolinas, I know in Georgia that we don't have a lot of infiltratable soils. It's a lot of red clay, but if we can capitalize on infiltration and allow water to naturally percolate into the ground, we'll do that as well. We try to do some more innovative outlet control design, and that's what I was saying with, we don't want to let all that water go at the worst possible time with respect to the upstream hydrology. If we can let it go at different times throughout the storm event, then we'll try to design that as well. And anywhere we can incorporate a pond as a site amenity to provide, I mean, it could be a nice natural open green space as well. Underground detention. Now, this is for those of you that aren't familiar with the concept, instead of digging a hole in the ground and letting surface water drain to it, we may put large diameter pipes or chambers or something underground and let the stormwater go to it that way. The most familiar one you might have seen is the large diameter corrugated metal pipes that you see built under parking lots, and today we see more of these chamber systems as well. But the idea is that you might not think of underground detention itself as being sustainable, but if we can co-locate some of our stormwater on areas that are impervious anyway, then we're freeing up the rest of our site for more green space, for less impervious area. And also, you know, storing the water underground allows it to stay in, you know, believe it or not, stay in a cooler temperature, so when it's released to the natural stream, it doesn't have the ambient heat increase that can cause problems in streams as well. So we'll try to incorporate underground detention where it's applicable as well. Some of the benefits, as I talked about, you can lessen the impervious area of your site with an underground system. Minimize the overall development footprint. We always talk about, you know, can we grade less on a site? Can we do less construction on a site? And underground detention helps us to do that. One of the great things is underground detention is really symbiotic with rainwater harvesting. And there's a lot of cool rainwater harvesting applications out there that can make use of some of these underground detention basins as well. And then we're minimizing the drainage structures and piping. We're not picking up stormwater in a conventional inlet and carrying it in a pipe way away to a stream on the other side of the neighborhood. We can keep the stormwater there and allow some of it to infiltrate. A lot of times, though, we can't get that infiltration into the ground from a underground stormwater system. So we do what's called a water quality structure. Now, these are, you've probably seen these and don't know it if you see some manholes in a parking lot where that are close together. Chances are that we have one of these structures in the ground. The idea is that the water flows into it. It's got some baffles here where it allows some of the hydrocarbons and the oils and the nasty stuff to be skimmed off the top, and then a lot of the heavier solids and whatnot will settle to the bottom, and then the cleaner water will come out in the middle, somewhere in between. So these are more of an active system, but they can, and they require some more maintenance, but they can clean the water up before we send it into a detention basin. They make a lot of sense in some more urban areas. But what one of my favorite best management practices are vegetated swales. Now, I explain to people that vegetated swales is really just, you know, industry jargon for grass ditch. And the reason why we give it a complex name like vegetated swale is because as civil engineers we can charge more to design it. But really, the idea is simple, is that instead of depressing our pavement to an area where we're picking all the storm drainage up in an inlet, putting it in a pipe and carrying it off to another location, what if we go back and look at a design where we can pitch some of our pavements to areas, grassed areas on one side of a parking lot or the other, or next to a building, provide some way, a curb notch or something to allow the water to get in, and then all of a sudden you're conveying your storm water to a pond or out to the edge of a site through a grass channel with all the phytoremediation, the plants that can soak up the pollutants. I mean, this is one of the best ways to to treat pollutants. We talk about the green streets. You're going to see more vegetated swales incorporated into right-of-ways. We have a monitoring station here where a county or city can go in and monitor the water quality that's coming out, in the discharge areas of these vegetated swales. So they're great opportunities to take stormwater runoff, high velocity, pollutant-laden stormwater runoff, and basically carry it out and provide some treatment as well. Now, there's a couple things we need to do in our design, or don't need to, but like to, is we try to, what we talked about, try to build pavement up or build site areas up and pitch water to these vegetated swales instead of, collecting it in a big floodable area. We try to locate these adjacent to impervious areas to pick up the immediate site runoff. We try to do the wide bottom swales with shallow side slopes. If we have a lot of steep longitudinal slope, we'll try to flatten that out or put the little rock dams in it. And the idea is that you want the water to sit in these vegetated swales, get some residence time, be able to be filtered in by the vegetation. So that's some of the things that we look at when we try to design these. Bioretention areas, everybody seems to know or at least heard of what a bioretention area is, but it's basically another simple concept. I mean, we're taking an area on our site where water would generally run to anyway, a landscape island or a depressed area, taking out the residual soils, excavating out the dirt that's there, putting back in some engineered soils. They're again a fancy industry jargon for soils that allow water to seep through. But the simple fact of allowing the stormwater to interact with the vegetation and filter through the engineered medium provides a whole lot of treatment in an area that we just don't think about. I mean, how many times have you gone in a parking lot and you just see a raised landscape area with different trees in it where it may be an opportunity to put a bioretention in for better stormwater treatment. There's different plants, water-loving plants that need to be planted into these bioretention areas, and some are better than others. But the different plants and fungus and root systems will actually provide really good stormwater treatment in a bioretention basin. And you can see kind of a schematic. I don't know, as an engineer I get excited when I see cross sections, but most people don't. But you can see if you cut this section away here in a bioretention area, you'll see that we have maybe a rock lens that kind of filters out some of the bigger particles, and then you'll have your 30 to 36 inches of engineered soil here, which is below this mulch layer. And then most of the time, or just about all the time, you'll have a perforated underdrain that picks up the water that sits in there. So the water doesn't sit there for too long. A lot of times you'll have more water than you can really handle in a bioretention area, and you'll have to have an overflow system as well. But we try to locate bioretention areas next to impervious surfaces that have a lot of fast runoff, pollutant-laden runoff. If it can get there quick, we can provide better treatment in the bioretention area. The exception to that is that if you were really close to the natural groundwater table, in what we call a stormwater hotspot, a lot of pollutants that come off, you don't want to have that much ability for the pollutants to filter into the natural groundwater. But we try to do vegetated swales in concert with bioretention areas upstream, possibly. We don't want the water to pond for very long in these systems. And then we want to, landscape it well and maintain that landscape. And the maintenance of these are important. I mean, you can't allow these to be, mucked up with sediments and trash, as they have to be cleaned out and maintained. This is an example, kind of a green street concept as well. This is a project that we worked on up in Ohio. We did an urban streetscape and street renewal where we're taking the runoff from this pavement and pitching it down with a slope into these faux inlets, if you want to call them that. They're basically curb notches. And then interspersed with the tree wells along the streetscape are these bioretention cells. Now, we had to do some retaining wall on either side because we're so close to the street in the middle of the urban area, but you can see the mulch layer here, the engineered fill here, and then the underdrains here. So we're providing almost all of the stormwater treatment and runoff control in the street right-of-way itself with this. And you can see a picture of it here. That's the plantings on top of the bioretention cells in that photo. Mm-hmm. That's actually the underdrain here. This is a 6-inch PVC overflow pipe. So if the water gets too high in this system and it can't seep down, it'll start to fill into this like a drain in your bathtub, basically, and then it'll take the overflow water out of the system. Rain gardens, there again, it's the same concept as a bioretention area. There might not be as much complex design in the engineered fill and the overflow, but we're basically taking the idea of, that parking lot again, where we have a mounded landscape island ringed with curb and gutter that's basically going to shed water away from it and down to the pavement. Why not do the reverse of that? Excavate the area out, put in some more infiltratable soils and some plants that can treat some of the stormwater and drain water to that area instead of away from it. And so that's just little ideas that we've done through the years to make more sustainable sites. We talk about pervious pavement and how good that is. There again, you're allowing water on the streets and concretes and driveways to infiltrate right there at its source rather than piping it or conveying it away. If you've ever seen pervious pavement, pervious pavement is kind of a catch-all for porous concrete and those grass pavers that have, a hard polyethylene structure that you can plant through. But, the porous concretes, when they get cored out, and you can actually see them during construction or during sampling, they kind of look like a Rice Krispie treat. You can pour water on the surface and it seeps right through. So if you have infiltratable soils underneath, it can go into the ground, or it can be picked up with an underdrain system there. But some of the things that we like to consider, because we're the ones designing, everybody in this room that's tied to the construction development industry, we're the ones designing and constructing these, so we have to be careful about a lot of things. We need to put pervious pavement on infiltratable areas, because it's not going to do any good if it seeps through the pavement and then hits hard clay that it can't go anywhere. It'll back right up. We want to try to keep it off steep slopes, fit the application to the intended use. We don't want to use grass pavers in high traffic areas. A lot of we want to keep the residual soil from migrating back up into the pavement itself. And sediment is the real problem. If you get sediment that can clog these porous concretes, then they just don't work. And if you don't plan and design correctly, then there's certain situations where I've seen counties and cities require the project owner to go write a maintenance spec to go out and vacuum his pervious pavement every 6 months. And that's kind of hard to sell on a project if you have a maintenance requirement to go out and vacuum your parking lot. Stormwater wetlands are extremely good best management practices as well. That the idea of we have the wet detention basin where water flows into it anyway. Maybe it's upstream of a good drainage area. So we've got water coming to a detention pond. Why not try to design that where we have some permanent vegetation there and even small ecosystems that can thrive in that area and also provide a lot of good stormwater treatment in that system. Plus, on top of maybe everything, be a great amenity for, a development, a residential development or a commercial development as well. So we do a little bit of different design. We try to do different shelves in a wetland basin, provide permanent pools where water will be there all the time, do different plantings and provide habitat for, different kind of ecosystems, different kind of plants. Now, there's some upfront costs with maintaining wetland basins, but over time they seem to the plants get established and they almost take care of themselves, and they're a thriving wetland treatment system basically for stormwater. So we'll try to put wetland basins in wherever we can do that. Vegetated green roofs. You have different spectrums on the green roof. you have a very elaborate system here with it's been established for years, and then you have a less expensive system here with smaller plants. But the idea is still the same. We're taking away that hard impervious surface that heats runoff up, and we're providing it as an alternative. Some treatment with the plantings itself, and an opportunity for water to absorb. Good vegetated roofs can absorb almost an inch of runoff from the site, or from a roof, and that's pretty significant if you look at that as a volume. I mean, that's pure absorption, where it's either taken in by the plants or it's evaporated through the air. So this is just kind of a cartoon site. We did nothing that we really designed, but it's kind of a palette of different areas where we might use these best management practices. We probably wouldn't use all these BMPs on one site like this, but here's an area where we might have some runoff to, conventional runoff in some pipes, but we might have a water quality structure here to filter out some pollutants before it goes into an underground basin. This is sometimes a necessary evil when we just don't have the real estate to do some of these other things. We may have some pervious pavement here. Here's the idea where we pitch some water towards maybe bioretention swales or basins or vegetated swales in the parking lot medians. And then maybe we have a nice vegetated swale before we go to a wetland basin and out to a stream there. So just some different areas where we might use some different practices. Want to talk about this project that we worked on in Charlotte, a case study we'd like to go over a little bit. The Cherry Senior Apartments, I'm new to Charlotte, but I think it's between Dilworth, Myers Park area, Queens University, that area of town. But it's kind of a transitional neighborhood. I think I like the area, but a good site for a sustainable project, maybe even a lead project. You've got pretty good proximity to pedestrian proximity to services and, transit and things like that. But the challenge that we had on this site, looking from a stormwater aspect, this was only a 1 acre site, and our parameters were to do 42 senior apartment units in a 3-story building, and then 22 required parking spaces. So if you do that math in your head on a 1 acre site, there's no more room left for anything else, including above ground detention. So we had to go underground with our detention. And that's when we hit the first roadblock, is that the city of Charlotte does not allow the water quality treatment per se in their underground systems. You can provide your storage, your detention storage in those systems, but they're not there yet on the actual treatment, the actual infiltration through. Hopefully this project will help get move in that direction. So that was our challenge. The first solution that we came up with was to go with a bioretention system. Try to get the treatment in the bioretention areas and landscape areas around the site, and then go to an underground system for storage after that. So you can see here is kind of a boulevard entrance with some planter areas here that we converted to bioretention. The problem with that is that it's a senior living development, and when you have, in order for us to get the requisite, elevations in this bioretention system, we were looking at having to do retaining walls on either side of these planter areas, with a deep system here because it's kind of compressed. So we've got, senior residents driving in and out of this this traffic pattern here, and then a lot of pedestrian movement up around this thing, and this vertical grade difference. It just seemed like a bad idea from the beginning. Just not a bad idea, but just risky in terms of liability. So we looked at some different options, and we were able to meet with Stormwater Services, Engineering and Property Management with Charlotte, and get them to at least agree to a pilot project on an underground detention system that provides water quality treatment as well. So this is called a StormTech system, and there's many others, but they look like big slices of banana. I mean, they're basically these large chambers. They're about half round with an open bottom. You lay them on about 12 inches of rock, and one special one you wrap in a series of of different filter fabrics, and the water comes into that first, and it allows it to percolate out. It traps the pollutants and sediments inside, and then it can fill up in high rainfall events and then start to infiltrate out of the ground through the open bottoms when the rain subsides. So we're able to locate these in different areas on the site, and that allowed us to do some good perimeter landscape area around where we would have had to do some other kind of stormwater detention. Charlotte actually installed 2 monitoring devices on the downstream ends of these systems, where they can go, their trucks can go in once a month and pop open this green box I'll show you, pull out samples, and they can test the stormwater for all kinds of different parameters to see if this system is working. I don't know what they're going to do if it doesn't work, but because it's already in the ground. But at least we were able to get them to agree. So we feel pretty confident that that it's a good program. Now, if you talk about cost savings, and that's a big thing with with going green with your developments, is how can you actually save costs? On this bioretention system that we had planned, the cost savings were fairly significant for a small project like this with going with the StormTech system. So, while the bioretention is a green system as well, we put some innovation into it and did some planning with the agency to be able to save some overall costs on that design and free up some more some property on the project side as well. And I talked about the monitoring stations, and here they are. There's one here on this side of the road and one here on the other, and they have a kind of a PVC clean out that they can go in, and they can pull these samples monthly. They can test for 19 parameters, E. coli and heavy metals, and just do an ongoing assessment of how that system is working. So hopefully for those out there that might have this system planned in their future, we've maybe paved the way a little bit for that. I want to conclude with a couple design examples. Now these are projects that we've got in kind of a design phase, and we sort of did this as an exercise where we got together and in a civil engineers think tank and looked at a site, an institutional site, a residential site, and a commercial site, and thought about it from terms of how would we do this, everyday planning design. How would we, go about doing this the conventional way, and put that on paper, and then turned around and thought of it from a different standpoint to see how we could make it more sustainable and what are the benefits of that. Now, certainly we're going to get, more natural benefit from that, better stormwater, better site design, but can we save money by doing green site design as well? The first one, and this is a kind of a generic, maybe institutional site, let's say a junior college campus or something like that. Maybe you have an auditorium, a residence hall here. And the idea here is that we've got a stream going through this project here. We decided that we would try to max out the parking on this side. Now this is the conventional approach. Max out the parking, put as many pipes and inlets as we had to pick up the drainage, get them somewhere either in a big detention basin here or across this stream into another detention basin here, because these are the low areas of the site, and grade this to the hilt to make it drain towards these areas. So that's we fit the land to the development instead of fitting the development to the land. And how many times do you see this in your site designs? Well, here's a different approach. First of all, instead of these large conventional detention basins, we try to minimize those sizes of volumes of detention that we needed, and did some wetland basins on other areas of the site where we were able to fit the development to the site instead of or fit the land to the development instead of the other way around. So we were able to get rid of 2 large detention basins here, plus a very intrusive stream crossing, blowing right through a stream with a pipe to get to a detention basin over here. And here's where the beauty of it comes in, is all this parking area here, we're able to do some different kinds of BMPs around it. Some pervious pavement on perimeters, vegetated swales, and bioretentions. areas in the parking lot itself. So we're doing more storage treatment at the parking lot source instead of piping it away to areas that just weren't right for that kind of development, and then providing some secondary treatment in areas that made more sense. And in doing that, you know, the cost, the sheer cost of that excavation to do those large detention basins and all the pipe and stormwater, I mean, this is almost a $1 million project. I'm sorry, a $3 million project, and we saved, you know, close to, and this theoretically in design, but in our design, you know, we saved close to $500,000 in earthwork and pipe costs. Now these are, you know, we went through and did takeoffs on the design to come up with this. So we really feel like there's some cost benefit to going green on this site as well. Here's the next example, kind of a multifamily community-style residential development where we've got, you know, your multifamily units, maybe some parking, a lot of impervious area, a lot of parking jammed in there as much as we can. Now, high-density residential isn't always a bad thing, especially in areas where, you know, different pedestrian-oriented services can support it. But, you know, how can we try to reduce some of the impervious area, do some better stormwater treatment, and get rid of these, you know, big, unsightly, conventional detention basins? Try to incorporate some better design into the community itself, some amenities, and try to save some costs. So this was our conventional approach. Our design approach, or our sustainable approach, you know, why not try to incorporate a stormwater wetland in the middle of the community? Reduce some of the sizes of these basins by going with wet detention / wetland basins. And here you see all these squiggly lines in here are areas where we freed up, you know, impervious area from draining through pipes to these different areas and carry them out of vegetated swales. So we're using the landscape to do some of the stormwater pretreatment and thereby reducing the overall volume that we need for the stormwater, and then putting, you know, wetland basins. And one of the coolest things about this is this whole brown area that was a storage, detention storage before, is now developable area for more units, or open green space area as well. So the bottom line on this is that you know, we saved you know, a project that's, you know, over $4 million, and you know, we had a pretty good cost savings on this. Our difference was close to $200,000, and most of that, again, is just an earthwork and piping costs that we can eliminate by doing some more sustainable measures. The last one, the big box commercial project that I picked on earlier, which, you know, happens to be probably some of our best clients, so we'll be careful about that. But we try to you know, incorporate better design for those clients to save money and be more responsible community citizens. So here's your typical example. You know, this is what we do every day. This is what we're programmed to do. Pipe all this drainage from all these low areas around this site and put it into one central underground detention vault, which is extremely expensive. You know, max out the parking, max out the impervious area on the site, and call it a day. We had some options here where we had two different criteria. We had maximum parking that that was required by the developer versus only the zoning required parking for the municipality. So here again, we used our strategy, try to get rid of this piping, try to get rid of the overall, you know, catch it here and pipe it away. Try to do more treatment at the site. All these pervious pavement sections, vegetated swales that the excess runoff can go to, some rain garden areas in the landscape islands, and, you know, gone you see is the large underground storage vault, which was a lot of cost on that site. Now, we had some different alternatives. That was actually the second alternative that you saw, but, you know, not only did we save a lot on the construction costs associated with that vault and all the piping, but, you know, we consulted with some real estate experts to find, you know, that outlot tenant prices and outlot or tenant rental rates and outlot prices, are better in sites that have more natural amenities. I mean, you're going to want to be in even a redeveloped site that has taken the time to do that kind of planning for better stormwater design, more amenable landscape areas in the parking lot as well. Last couple slides here, I just want to kind of show you a different kind of spectrum of development. We talked about the low density development where we have curvilinear streets, a lot of open areas, lower densities. That's on one end of the spectrum. The other end of the spectrum, high urban area, lots of impervious area, maybe a town center, and the differences between the two. And I show you that to kind of show you the applicability of some of these things. In your lower density areas, things like, your detention basins and your vegetated swales where you have the land to be able to do this makes some sense. In your urban areas where you don't have a lot of property to do these larger devices, then some of the things like the green roofs and the pervious pavements make more sense. It's kind of hit or miss across the board with the different types of development that we went through. I guess it's not going to want to cooperate with me, but some institutional, we have that, a lot of green space, typically more land that we can do some of the bigger devices on. Redevelopment in urban areas, we're going to look at, opportunities that we can do, pervious pavers and whatnot. Residential, we'll try to do wetland basins as well. So it's kind of across the board there. So that just kind of gives you a little run through on my on my presentation. The BMPs that we use in design, the case study in the city of Charlotte, and then some design examples. So with that being said, I'll open the floor to any questions. Yeah. I can try. Unfortunately, I haven't done a whole lot of bioretention design in Charlotte itself, in the Carolinas, but I have done quite a bit in Georgia and the Southeast. And he asked about the success of maintenance for bioretention areas in this area. It really boils down to what your prescribed maintenance is with the regulatory jurisdiction, the municipality. There's a lot of maintenance specifications that have to be followed, and a lot of times they're stringent. And if you're a developer or a project planner, and you're going to get red tagged for a bioretention system because you can't keep up with the maintenance, then it might not be a good idea. On the other hand, though, you got to know going in that plants are going to have to be replaced from time to time, that sediment's going to have to be excavated out of these bioretention systems. So I think that I can't speak as much to the Charlotte area, but I can tell you that it's kind of hit or miss in different Georgia municipalities as well. Yes, sir.
That's actually one item I noticed in this thing that cost me.
Maintenance.
Maintenance over 10 years is $1,000.
Absolutely, absolutely. And you're absolutely right. You're going to have those maintenance costs associated with a lot of the sustainable elements, but you're also going to have a lot of maintenance, and it may be spread out in different increments, but you're going to have a lot of maintenance with conventional detention basins as well. I mean, you're going to have to go in and hire a grading contractor to go excavate out sediment on a periodic basis. It may be a lot more frequent than you want to, based on what's upstream of your site. So I think I think that you're going to. It's probably not apples to apples on maintenance costs. You probably do have some more, specialized maintenance with some of these stricter or these stormwater BMPs than you would with conventional detention ponds. But you're not going to get away from it entirely, either way you go.
Have you found that the use of the water treatment structures is a more efficient way to address the maintenance issue, rather than have to go into a more natural, say, a surface structure and excavate a pond and rebuild it?
Well, I guess when you say the systems that you're talking about, the water quality systems, they're very maintenance intensive. You know, usually the company that sells the system will also attach a pretty high cost maintenance program with it, but they'll come out every quarter and have to pump that system out. So, I mean, those things they collect it. They collect they collect the hydrocarbons, the trash, the oils, and they have to. I mean, they're specialized on their pump outs. You know, with bioretention systems, other more natural treatment systems, it's not difficult to think that you could get your regular landscape contractor or maintenance facility to go out and educate them to do what it takes to do the proper maintenance, but it's not as specialized as the water quality structure system.
Especially with the issue of where you're going to take the stuff down and pump it out.
Absolutely, yeah. I mean, that's not something that you can just put in the trash can and take to the landfill. Yes, sir.
My experience with the bioretention things, a couple issues. One is plants in the summer that love water, all of a sudden are sitting in the Sahara Desert, they die. Animals eat them. And then the sandy, the engineered soil, you get paid a lot to design, charge us to buy. As soon as you get this much clay on it, it blinds off, it doesn't percolate through, and this whole area is pretty much clay.
Absolutely.
So if you don't have an owner that is willing to stabilize their site, and that's not putting seed down, it's probably more like sod around these things at least.
Sure, there's all kinds of examples where you can see where, the bioretention in the terms of the elevation of the site, here's the bioretention system here, and here's a whole unstabilized area of development up here that wasn't grassed properly, the slopes weren't stabilized, so all the sediment that runs off of that upstream area ends up covering the bioretention area, and that's when you get fines from counties or cities to go out there and have to clean that up. So it's all it's a holistic approach to the site design. You can't put the BMP in an area it's not going to work in. As far as the water getting to those plants, there has to be a minimum design. I mean, there has to be plants that not all bioretention areas are going to have cypress trees in them or some kind of other water-loving plant. But on the other hand, there might not be as many drought-tolerant plants in those. So good landscape architect on the team is critical as well. Sir.
Is there a potential for, it just seems like stormwater guidelines in general are just on the increase nationwide. Is there potential for some cost payback on these types of systems? Or decrease sampling requirements or higher quality stormwater leaving the site?
Well, I think you're seeing that, if the gentleman asked if there's any kind of payback on some of these stormwater systems with all the increased stormwater regulations that we're seeing today. Sampling requirements. I think what we're seeing, and Charlotte has this, and a lot of other large municipalities, stormwater is basically being regulated like any other utility, whether, potable water or your sewer or gas or whatever. You're getting charged for the stormwater that your site, causes to run off. So there's more and more opportunities now to go back in, and there's programs through cities and counties to go back in and show where your BMPs are working effectively and get some reduction off of those utility fee costs. So I think that's where you're going to see some of the payback, is that, if you're right, reduction in impervious area, better stormwater treatment, maybe the monitoring of certain pollutants can be tied into that fee as well. If you're doing better on your contaminant levels, then you'll have an incentive to pay less in fees as well. I think I ran out of time, but I'll be here. Please feel free to ask me any questions. And thanks for your attention and time.